Okay, so I'm going to do what I was going to do for a seminar today because it doesn't look like I'm going to be able to get to school this afternoon. So I'm going to show you what you need, plus a little more, but what you need for reading quiz 2, and hopefully will get uploaded before you leave school. So dispersion is spread. Range is a type of dispersion. That's where you just take the highest value and you subtract the lowest value. Variance is a question of how different things are from the mean. So real quick, let me tell you, so we've talked about 3 kinds of average. There's another kind of average that isn't taught anymore just as an average on its own, but it was at one time. And the point of this one is to get a handle on the general size of things, and so that even if they're negative, then you get a good shot at them. It's called RMS, and it stands for root, mean, square, but that's in the reverse order of what you do. First you square everything, then you take the mean of that, then you take the root. And it's called an RMS average. So then basically if you have like these numbers would average to 0, but so would negative 200, 300, negative 500, 400, negative 400, 400. So the RMS average takes the magnitude of everything so that you square it first. So now everything's positive. And then you average this. So you would add these up, 13, 38, 54, 70, 86 over 6. And then you take the square root of that. So you've squared it and you've rooted it, and it doesn't turn out like if you just taken the absolute values and averaged them, it's a bit different. But this actually turns out to be useful as far as standard deviation. So essentially, if something's bell-shaped and symmetric, then you use the standard deviation for a measure of spread. That's not the case on things that are skewed, but if it's basically bell-shaped. So the variance is notated s squared because you generally don't talk about the variance. You almost always just talk about the standard deviation. So what you have here is each value, you subtract the mean from it, so that's the deviation from the mean. Then you square that. Then you divide by n minus 1. And the reason is because the sample size affects how good your estimate is. So because standard deviation is an error of sorts, it's how far you're likely to be off, if you have a sample of, say, 10, then you're dividing by 9 instead of 10, and that makes a pretty big difference. But if you have a sample of 500, which is a pretty good size sample, the difference between 500 and 499 is really not anything as far as dividing. So the bigger your sample, the less this n minus 1 hurts you. If it's the standard deviation of a population, you divide by n, not n minus 1. Okay, so this is s squared because, again, it's the square of the standard deviation. So you find the variance, and then you take the root of it, and all you've really done is square, mean, root. It's just that you divided by n minus 1 instead of n. So for notation, sample standard deviation is called S. Population standard deviation is sigma. So I told you before, the population gets the Greek letters and the sample gets the ordinary letters. So the variance is S squared, sigma squared. I'm just giving you a second to read that one. Okay, so here's a list of numbers. That's travel time in minutes for 9 students enrolled in the statistics course. So we want to calculate the range, the variance, and the standard deviation. The range is easy to do, so I'm just going to go do that. And then I'm going to see if I can use the concatenate function in R to do the variance and standard deviation. Okay, so biggest number, so the range is the biggest number minus the smallest number. And that's it. That's the range. Done. Okay, let me see. We concatenate 39, 21, 9, 32, 30, 45, 11, 12, 39. Okay, so now I've named x to be this list of numbers. So I'm going to find the mean of x. 26.4 repeating. So now I want y to be x minus 26.444. Okay, well that did spit something out, so that's good. So that's the deviation. So I've taken every value in x and subtracted from it the mean. Now, that's the deviations, so I need to square the deviation. So now, once I've got the list of deviations, which again is just subtracting the mean from every one of them, then I need to square then mean, except n minus 1, and then root. So z is going to be y squared okay. I wonder if I can just do some, let's see. Yes, I can, okay. And then what if I want sum of z divided by 8 because there were 9 values? Okay, and then I actually want the square root of that. Okay, so there is the standard deviation of those values done in this. And so now that we've seen how to do it, you can do it quicker by not doing that line in 3 pieces. Good, okay, so there's the standard deviation. Oh, and the variance was the one before we took the root. So the variance was 185.5, and the standard deviation was 13.6. Okay, so this one we want to find the standard deviation for each of these groups and then figure out which one has more variation. So more variation means higher standard deviation. Okay, so I'm going to concatenate. I'm going to run the mean. And then I'm going to make y that minus the mean. I'm going to square the values. Instead of dividing by 8, since there's 6 of them, I need to divide by 5. Okay, so the first one has 0.199. And that one's 0.0647. So that's much, much smaller than the 0.199 from before. So this one has a lot less variation, so the first one has much more variation. Blue. So here's the empirical rule if something is bell-shaped. So only if it's bell-shaped do we really want to use mean and standard deviation as our descriptors. About 68% of the data are within one standard deviation, either direction from the mean. So if you take the mean and add a standard deviation, and then take the mean and subtract a standard deviation, about 68% will be between those two values. If you add and subtract 2 standard deviations instead, about 95% is in there. If you add or subtract 3, there's about 99.7% in there. So later you'll have more exact measures for these things, but this is just the empirical rule for this. So here's an example. Normal adults have a bell-shaped distribution with a mean of 100 and standard deviation of 15. That's IQ scores. I have this bell that was drawn over there. There's 1 standard deviation, 2, 3, 1, 2, 3. It's symmetric, and this is 68, so that means these are 34. This altogether is 95, but 68 is there, so that gives us 27 left, so 13 and a half. 13 and a half. And then what's left for these 99.7 parts, that gives 4.7 more between them, so 2.35. And then there's 0.3% left in these, so 0.15. Okay, but again, you've got it in your notes right here. So approximately what percentage of adults have IQ scores between 55 and 145? Well, here's 100. This is adding 1 standard deviation, adding 1 standard deviation, adding 1 standard deviation, subtracting 1, subtracting 1, subtracting 1. So between 55 and 145, that's from -3 to 3, so that's 99.7. Greater than 145 is just that 0.15 of a percent. Between 85 and 130, so we have 34, 34, and then that 13.5. So 81.5%. So we're just looking at these pieces and just adding them up for right now. Okay, so SAT math scores, mean of 515, standard deviation of 114. So 515 goes in the middle. Add 114. Add 114. Add 114. And of course, we can't go above 800, but because of the SAT score, but we'll pretend. Okay, subtract 114. Subtract 114. Subtract 114. Okay, so between 401 and 629, that's just 1 and 1. That's 68%. And then lower than 401, well, this is 68. So these two together make 32. So this one's 16. So the key is it always adds up to 100. I'm going to temporarily skip the z-score part, and we'll come back to it later because this is on reading quiz 2. Okay, percentiles you've heard of before, and we'll get into this more, but I want to hit the quartiles right now. So if you're at the 53rd percentile, that means 53% of all values are at yours or below. So that's what percentile means. Quartiles separate 25, 50, 75. So it splits it into 4 pieces. The bottom 25, the second 25, the third 25, and the upper 25. So the way you do this is you find the median, and then you look on either side of the median, and you take the median of that, and those are your quartiles. Some books have you include the median on both sides, and some of them have you ignore it on both sides. And I think that your book for this course and RStudio do different things. But so if I take these numbers, which have already been ordered for me, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 of them. So 1, 2, 3, 4. There's the median. The median also called quartile 2. And then over here, if we do include this value, then we have 9, so it'll be 1, 2, 3, 4, 5. This will be Q1. If we don't include the median, then we would average these two. And 65.5 would be Q1. Over here, same thing, if we include it, then that's Q3. If we don't include it, then Q3 is right there. Okay? So if you have, and then this is min and this is max. These values make up what's called a 5-number summary. So 53, 66, 75, 84, 93, or 53, 65.5, 75, 85.5, 93. That would be the 5-number summary. Okay, so there it is. So that means that they do include the median, and so I think that means your book doesn't include the median. So min, quartile 1, quartile 2, quartile 3, max. Quartile 2 again being the median. So then If you have a skewed distribution so that you can't use mean and standard deviation, what you use is median and interquartile range. So interquartile range is going to be Q3 minus Q1. Q3 minus Q1. So in this case, 84 minus 66, so 18. So it's like the range, but it's just the inner quartiles, the range of those. And the way you check for an outlier is you take Q1, you take the interquartile range and you multiply it by 1.5. You start with Q3 and you go out 1.5 IQRs. You start with Q1 and you go back 1.5 IQRs, and that's how you find what's the expected range of values. So in this one, well, I guess we can use this one. I'm not sure how that one's skewed.
Fresh brew in Sirius XM's coffee house. And cheer, Tenerife City.
Okay, so that has 20 values. Okay, so we have a mean of 10.08, a standard deviation of 1.89, and back here I have the median is 75. Oh wait, the median is 9.95. The IQR is 11.1 minus 9.15, so that's 1.95. Okay, so the mean and standard deviation, 10.08, 1.89. Cat named Daisy had a hemoglobin level of 7.8. Calculating her z-score is something I didn't go over just for the purposes of answering the question. I'll tell you quickly, but we are going to go back over this later. It's just how many standard deviations away are you from the mean and in which direction. So what you do is you subtract from the mean and then divide by the standard deviation. So negative 1.2. And that just means she was 1.2 standard deviations below the mean. The IQR was 1.95. So the fences are then Q1 minus 1.5 IQR, and Q3 plus 1.5 IQR. Q1 Q1 was 9.15, Q3 was 11.10. So the part that's always the same is the 1.5, and then these you'll substitute in the values. So that's 7.025. 14.025, and the question is, are there any outliers? So if I look at these values, the biggest one is 13.4, the smallest one is 5.7. So I want to know, are they outside this range? The 13.4 is less than this, so it is not an outlier. But this 5.7 is less than my lower fence, so 5.7 is an outlier. Okay, so for your data set, if the distribution is symmetric, then you use the mean and the standard deviation. If it's skewed, you use the median and the IQR. And you'll see that the standard deviation and the IQR aren't very different in this case. So if you're trying to compare two different data sets and one of them is skewed and one of them isn't, the safest thing to do is use the median and the IQR, because the one that's symmetric, the mean and median should be about the same, and the IQR and the standard deviation won't be too far off. So we're going to do z-scores and box plots next time. And just real quick, one other thing, because I already talked about before how if it's skewed like this, that means the mean is larger than the median. Note that the mode is going to be wherever the tallest part is. So in this case, here's the mode, and then the median is after that, and then the mean is even after that, because the mean got shoved to the right. So you ought to more or less now be prepared, I think, to do quiz 2. So I'll get this posted as soon as I can here.